Okay, we are live. So, good morning, guys. I am
Good morning.
Francisco. Yeah,
Hey
good
guys, how you
morning,
going?
Ryan. Good morning, Troy. Welcome here. So, welcome everyone to the very first webinar of PoliSpace. I am Francesco Ventre, the president of PoliSpace and one of the co-founders. And I'm here just to talk for a 2 minute talk about what is PoliSpace. And then I will leave the floor, of course, to Troy, which is the protagonist of this webinar. So again, thank you for being here to attend this webinar, and we are so glad to have you. So, what is PoliSpace? Well, PoliSpace is an association that was born from a dream. So the dream of 3 students like you, because also me, I am a space engineering student, as well as my colleagues Swarna Jodi and Aloysia that helped me in building the association. So this dream was that each student should have the possibility of carry on hands-on space-related project, and we would like to spread the aerospace culture in Politecnico di Milano. And for a space culture, we mean everything which is space and aeronautical related, apart from engineering, of course. We have many side of these fields, like, for example, space law and etc. Which is our philosophy? Well, we would like to allow students to learn by doing. So we would like to abandon this philosophy of the theory, of the theoretical side, and we would like you to get your hands dirty, let's say. Up to now, we have 40 executive members in PoliSpace, which are working, as you can see, for example, today, the result, in various fields, like the graphical side. We have bloggers, we have guys business related, we have also guys that concerns about the research and development of our projects. Regarding the project, we have one incubated project, meaning that in future you will be allowed to make your own proposal about the project that you want to develop, for example, with a team for ESA opportunities, like fly your thesis or build your thesis and so on. Up to now, we have one incubated project, which is designing a Mars mission for the AAAA Mars Sample Return competition. Indeed, we have also one big ambitious project, which is a long-term project. We would like to build the first ever nanosatellite entirely built by students in Politecnico di Milano, and we want to launch it in a very brief time. Yeah, what I can say more? We are so enthusiastic, and we are so happy that we could have organized this webinar with Troy, which will talk us about how to start a space startup and how to develop it. And I invite you to subscribe to our social media if you're not, and also to our newsletter using the website polispace.it. And that's it from my side. So I leave the floor to Lyle and Troy, and thank you for being here.
Great. Thanks, Francesco. So it's my pleasure to introduce Troy McCann. Troy has a degree in electrical and electronics engineering from the University of Melbourne. We met originally at the Formula SAE, Formula Student event. There's a competition in Australia every year in Melbourne. Since then, Troy has become a leader in the Australian space industry. Our listeners may not be aware, but Australia is experiencing a rapid growth in our space industry, which motivated the creation of the Australian space industry 2 years ago. Today, Troy will be giving us his thoughts and experience about space and the industry in Australia. Today, we have a mixture of questions from myself and the audience, and I guess we'll get started. How are you doing today, Troy?
Yeah, really good. Thank you very much, Lyle, and thanks very much, Francisco, as well. It's great to be here.
Yeah, good. I'll start with the first question then. Can you give us just quickly a bit of your background and how it led to you getting involved in the space industry?
Yeah, so my background is kind of interesting, I guess. So like you said, Lyle, we met back when we were both young students building race cars at university, which was pretty cool. And on my side, I can't speak on behalf of you, Lyle, but I know for me, I had no idea what I wanted to do. I was just having fun building race cars, and I was very much, as an engineer, I like to be very hands-on. Was not a big fan of the exams and things like that. But particularly as I got close to the end of the degree, I really had no idea what an electrical and electronics engineer was supposed to do in Australia, unless it was to go work in mining. That seemed to be, or big utilities. But I was more interested in electronics and the real sort of high-tech stuff. So it was sort of good, I guess, that I discovered these things called CubeSats. Towards the end of the degree, I just, after 3 years of building race cars, I just said, okay, I should do something else. Just discovered these things called CubeSats. A group of us got together and just kind of thought, well, to be honest, you're getting a little bit of an interesting story today because you mentioned the Formula SAE thing, so I'm tying a lot more of that into it. I sort of thought, well, can I develop a space program that was very similar to Formula SAE, less about competition, but more about air? How can we do this really cool thing? Australia didn't have a space agency at all at that time. In fact, us, when we were getting that group started, we didn't know of any space stuff happening in the country at all. So we thought that, arrogantly, that we were the only ones doing anything with space, and said, well, how do we build a satellite? Okay, surely it can't be too hard. There's high school kids on the other side of the world doing it. Really, when you break it down, like a satellite, you would think is complicated, but it's really just a electronic circuit, and you just basically turn the comms up a little bit so that you can get your link budget to connect between space and Earth. Easy, right? Well, I wasn't too far off, because I quickly realized that the biggest challenge for us wasn't going to be the engineering, the technology at all. It was actually going to be everything else around it. If we're going to build this satellite, well, how do we convince our government to give us permission to launch it? How do we convince the university or whoever, our sponsors, to give us the money that we needed to actually build the thing, to have a lab, to organize the launch, to get insurance? And so one of the first things that I did, because with our Formula SAE team at the University of Melbourne, it was all engineers. It was engineers doing, the marketing and stuff like that as well, or trying to find sponsors and things. And I always asked, why don't we branch out and get other parts of the university? So in building the Melbourne Space Program, I first went to the Melbourne Law School and said, hey, which of the law students wants to come and help us build a satellite? And so we had a whole bunch of people put their hands up. And so that was sort of the first step for us to building a really interesting, proper space program, where it wasn't just about the engineering. We had lawyers, or law students, I should say, that were looking at our space activities regulations, and eventually we got invited to go to our parliament and advise on what those what the updates and revisions should be, which has now led to the Australian Space Agency in part. We had teaching students that were going out to local schools and teaching space and getting children more engaged with it in a very different way to what was being done before. So we had people from all kinds, and that was really cool. So I did that for a couple of years, and so we eventually did build a satellite, and we launched it. With the first student group in Australia to have launched a satellite in 50 years. So unfortunately, we didn't get the medal for first, because a group of University of Melbourne students had actually built one in 1967, and NASA launched it in 1970. So we became really close with those guys as well. That was Australis Oscar 5. And so that was a really interesting experience. So for me, like I said, I didn't know what I wanted to do for myself. I fell into entrepreneurship. A friend of a friend came and said, hey, you can do electronics. Can you make this thing internet connected that I sell? I said, yeah, I'll give it a go. I ended up working with a lot of academic teams, commercializing electronics and eventually mechatronics research, and getting it ready for manufacture and stuff. And so doing this Melbourne Space Program, because I'd graduated by that point, on the side of accidentally falling into entrepreneurship and commercializing deep technology-based things, I said, well, how do we bring these two things together? Space today, it's more than just about, saying, all right, we've got this CubeSat, cost us a couple of $100,000 and we can get it into space. Instead of it being an academic exercise, what if we turn it into a business? For less than a fraction of the cost of an investment property, you can start your own space program now, a commercial one. space is, incredibly valuable across a whole bunch of domains that most people don't even think of. So how do we challenge that? So there's an interesting story about an elevator pitch with Buzz Aldrin that maybe you can ask me a question about it. But that was sort of the turning point where I sold off all my companies and said, I'm going to start this thing called MoonShot, and I'm going to try to help 1,000 different startups grow and use this experience that I've got to grow new space companies.
Yeah, that's very interesting. You answered about 3 or 4 of my next few questions in one go.
Sorry, I thought I should hold up, or you won't get another question in.
Well, since you mentioned it, can you tell us about your elevator pitch with Buzz Aldrin? I think everybody here is familiar with that guy.
I hope so. So there was this interesting time where, so like I said, I had another company I had the Melbourne Space Program that I was running. I had another company called Ubiquitous, and we had a spin-off medical device company at the same time. And I made this decision in mid 2016. I'm like, I love the space stuff, but it's just it's a thing I'm doing on the side as a hobby. I really have to focus on the things that are keeping a roof over my head. And 2 weeks after I'd made that decision, I'd handed over the baton for the Melbourne Space Program, and I was still invited to this. So Buzz Aldrin came to Australia with National Geographic and was going to do this show about Mars, Mars Live Experience, talking about why Mars is a milestone that humanity should strive for very soon. And I was lucky enough to go to a VIP function just beforehand, and a couple of friends of mine were there as well. So there was one lady who so some of you might have heard of her. So she's an Australian from Adelaide. Her name's Andrea Boyd. So she works at the European Astronaut Centre up in Germany as the International Space Station flight controller. And so her job is to talk to the astronauts on the ISS every day. So when they say, Houston, we got a problem, she's not necessarily always in Houston, but she's the one that they're talking to. And so she was back in Australia as well because she was helping, I guess, lobby the government on building the Australian Space Agency. And Buzz came and spoke to everyone in that VIP audience. And I was just standing back, just happy to be there. Told myself, I'm not going to bother him, even if I had the chance. And lucky enough, I didn't, because he was late to get prepared to get on stage anyway. So he spoke for about 30 seconds at the front, and then he finished, and so he was walking up. So it was cool to listen to him. And Angie wanted to take this really odd picture. She's like, Troy, turn around. I want to get a picture of you and Buzz. I'm like, well, there's like 100 people in between me and Buzz. This is really weird. And I don't know if she planned it this way, because that meant that my back was turned to Buzz. And as he finished up and the crowd was dispersing and I was turning back around again, all of a sudden I get shoved in the back. And before I realized what happened, Angie shoves me a second time and I got like whiplash. And she's like, Troy, go, get in there. So then all of a sudden I realized we're rushing down this corridor and surrounded by Buzz Aldrin and his security entourage. And one of the security guards turns to us and says, who are you two? And Angie's like, no, don't worry, he's with me. And I'm thinking, like, have you done this before? We get to the end of the corridor and someone's frantically pressing the elevator button, and people start to realize there's two strange people here. And Angie says, hey, Buzz, I really just want to introduce you to a really good friend of mine. His name's Troy. And someone cuts her off and says, no, he's got no time, like no time for this at all. And the elevator doors start opening, and someone else says, no, just get in the elevator. And this all happened in probably like 15, 20 seconds. And before I realize it, I'm getting literally pushed into the elevator with Buzz Aldrin, and the doors close. And it was just the most surreal thing. I never thought that I'd ever find myself in a position where I'm giving a literal elevator pitch, especially to an Apollo 11 astronaut. So truth be told, I don't really actually remember exactly what I said, but in hindsight, I know what I must have spoken about, because I was so anxious that my heart must have been racing at 200 beats a minute. And all I remember is thinking, I don't want to bother Buzz. He doesn't have, I've got nothing really that valuable to tell him. He's got people swooning over him all the time anyway. And I remember finishing and the doors just weren't opening. It felt like it took forever. I'm like, someone please put us out of our misery. He's just staring at his feet. But thankfully, when the doors did open, he looks up at me and he's gone, that's fantastic, because I'd just spoken to him about my thoughts about space entrepreneurship as a thing that we should strive for, and what I thought needed to happen in Australia and the rest of the world, and he absolutely loved it. And he's like, Troy, you've got to meet my son Andy. He's working at the Florida Institute of Technology. He's building a school for space entrepreneurship. You have to meet each other. And he spent the next 5 minutes or so fending away his people that were trying to get him to get ready to get on stage, just talking to me about space entrepreneurship. And long story short there is that he did get me introduced to Andy, and we had this great initial chat about how, the problems that I was trying to solve in Australia were really the same problems all over the world. And that's because space now is entirely different to what it was 5 years ago and 5 years before that. The commercial space sector now is just brand new. The fact that we develop, the satellite engineering is now around small satellites that we put into low Earth orbit. We expect them to work for a couple of years before they burn up, and we're launching constellations as opposed to a half a ton geostationary satellite that might have to run for 15 or so years just to become commercially viable. Everything we do is entirely different. And so it was at that point that I realized, I'm like, okay, I've got to cancel everything else, like sell off all the other businesses I was running on. I'm going to go back to space. It was a two-week decision where I'd left the Melbourne Space Program, and all of a sudden I was all in 100% on space stuff, all because of Buzz Aldrin. And so today, Andy Aldrin is one of our investors and our mentors still. He's been on my advisory board since all the way back in 2016. Yes, it's been fantastic.
Great. Could you then give us some more detail about MoonShot and what you do and how you solve? You mentioned before that there's a new variety of problems with the space industry at the moment. And can you talk about how MoonShot helps solve those?
Yeah, for sure. So one of the things that, when I first started MoonShot, I recognized that space technology is much easier to build and to deploy than most people realize. And so I just proven that, at the Melbourne Space Program, we raised 270,000 Australian dollars from our university. And we managed to build and launch a satellite with that, all it does, which is, it's a huge feat, because we were just a group of amateur students, but beeps out and it says, hey, if found, please return to the Melbourne Space Program. That's pretty cool, but we could have, in hindsight, I wish that we had done something more with it. But it just goes to show that there's a whole bunch of opportunities from Earth observation to if you wanted to start looking at machine learning payloads to optimize your bandwidth, data that you're sending back down to Earth, and a whole bunch of things that you can do. So how can we help more companies realize that and start to commercialize those? The current frameworks to help startups and tech startups grow have really become very focused on software companies. And so accelerator programs and a lot of investors even just simply don't understand or are blocked. It's like they've got blinkers when you mention the word space. They still think that it's, it's something that only the big billionaires can do, or that it's something that's, it's not going to be profitable for 20 years or so. And it's all just, and pardon the puns, pie in the sky. Never going to happen. But we know that that's not the case. And we know that today, I think, what was it, in the last quarter, there was almost $5 billion of investment that went into space startups across roughly 50 companies. Since 2009, we've had, I don't know, I can't remember how many billions of dollars that have gone into space. We're sort of at this turning point now where we can see that there is a lot of commercial space opportunity there. Not just selling contracts to governments and for big government space programs that are contracting and having prime contractors sort of filter and trickle down funding through the supply chains, but there's actually commercial opportunities there now as well. And companies that are doing things like aggregating data sets from a whole range of Earth observation providers and things, and then making that accessible both in terms of pricing for farmers that need to optimize their crop yields, or city planners that need to, that can use that data that's coming from space, and new sensors like synthetic aperture radar and all this kind of thing are opening up new opportunities there. There's a whole range of commercial opportunities. So what we do at MoonShot, we have tried to recreate that framework of of accelerators, and we've just, so some news that's about to come out in the next couple of days. So this is, keep it quiet, everybody. We've just closed raising our first own investment fund ourselves that we're going to use to invest into space startups from across the world. And that's something that we're going to grow in capacity from every year from now, so that we can give them the capital that they need, so that we can signal to other investors that, hey, MoonShot's put our stamp of approval on this opportunity. You can trust that this is something that's actually real and viable. We provide access, so we're doing a lot of partnerships with universities and groups and organizations with facilities like thermal vacuum chambers and things like this that are usually really hard to get access to, so that we can make sure that the startups that we're working with can access them. And that we can reduce a lot of the friction in going through the process of getting a launch license, depending on the nation that you're from. We're talking with companies like Axiom Space, who have just got NASA's very first commercial contract to build a new habitat module for the International Space Station, and they're looking to build their own private space station. They're trying to rapidly expand the amount of what I describe as space in space that we can now use. So rather than saying, I want to test this payload or do an experiment, you don't have to build your own whole satellite bus anymore. You can actually just, basically pay them and pay for a service where they will carry everything up into space. They'll put it onto the International Space Station. You can run your experiments and things there. It's like a service now that you can access. So there's a whole bunch of opportunities. We're just trying to connect them all together. So we're bringing together, the investors with the startup founders, with the people that will work in those companies, with governments and all the different stakeholders together. And the way that we describe it is, it's a rising tide that lifts all ships kind of scenario. So the way that our investment fund works, for example, is that it's actually led by, at the moment, mostly Australian space leaders, but also people from across the world, like Amir from Axiom Space. There's a few Europeans as well who are chipping into this. And they're also mentors. And that's the idea that we want to grow, is that we want to help grow these startups so that the people and the entrepreneurs within them, they can get to a level where they can eventually contribute some both time as well as money into that next generation. And using that, I assume most people watching this are engineers, so you get the concept of the positive feedback loop. That's what we hope to establish with this, is this positive feedback loop of growing the success of these space companies that are doing these incredible, remarkable things, and then helping the next generation grow and so on and so on. So it's a little bit of a strange model. It's a bit different because we're not, not the traditional kind of investment fund where we're looking to just say, here, have some money, and then, hopefully in 5-10 years time, we want to see some returns. We're really sort of getting into the mix and trying to help grow. The investments go beyond just the capital. It's access to facilities, it's access to networks, it's providing international connections so that you can get better access to potential contract opportunities and things like this as well. And it's just about reducing a lot of that friction that's currently in the system that prevents things like space companies from getting off the ground.
Yeah, great. That sounds very interesting. Can you tell us a bit about some of the startups you're working with and what their technologies are or what their goals are?
Yeah, so surprisingly, as much as we talk about focusing on space, I might just preface this with, I guess my quick philosophy around what I consider space to be. So I think a lot of people unconsciously think about outer space as this place that's elsewhere and the Earth is entirely separate, whereas I try to flip that on its head. I think a lot of us watching this will probably agree, our planet is a tiny spaceship and, it's floating amongst the stars. And so we understand the concept of, well, we're already in space. But I take it a little bit further and say, well, what we expect to be special about space isn't actually space itself. It's the fact that there's frontier locations in physical space that we have access to. And so from that perspective, it also doesn't matter if you're, for example, doing stuff in the deep ocean. It's about understanding that the Earth orbit provides very different properties to somewhere like Mars or the Moon, or having a look at an asteroid like we just did this week, or the Japanese did this week with the Hayabusa 2 mission. These places are all different. So it's understanding space in terms of frontier locations and the different perspectives that they give us to solve big problems. So that's how we break it up. Now, I think in the short term, a lot of companies will find it much more easy to do commercial projects in like Earth orbit, for example, versus saying, all right, I'm going to do stuff on Mars, because it's very hard to get to Mars at the moment. But I also find it really interesting what terrestrial. So, and I promise I will come back to your actual question about startups I'm working with. But I find it really interesting to, when you look at companies, terrestrial companies that are starting to break into that space economy. Like Microsoft a month ago or so announced a successful trial of a underwater data center. Basically, they sealed it all up. They put it underwater. I think it was off the coast of Scotland or Ireland for a couple of years. They discovered that it had roughly 20% better power efficiency, but it also meant that no one could go down there if there was any issues. So it's kind of like may as well be in outer space. And so it's about looking at these frontier locations and how we can use them. You've got Axiom Space are working with Tom Cruise and others to send Tom Cruise up to the International Space Station to record films. So film and television, Estee Lauder are now using the International Space Station as well to record an advertisement. And so these things might seem like they're quite shallow, but then you've got companies like Nokia, were just given a big contract with NASA. I think it was roughly 16 million. It's actually cheap in the grand scheme of things, but to build a 4G network on the moon, because they know that they're going to need that. Toyota have just announced a partnership with the Japanese Space Exploration Agency to build a sister model to their Toyota Land Cruiser called the Toyota Lunar Cruiser. And it's literally going to be a lunar module. So we're seeing a lot of these terrestrial companies start to break out into space. So when we look for space companies, we're not just looking for the companies that are building rockets or satellites. That's obviously a really core, exciting part of it. But we're looking at, more, how are they leveraging frontier locations? So a couple of the companies that might be considered outliers by most people that we worked with recently are, one of them was called, or is called Swoop Aerospace. So they basically have these really novel drones that they've been 3D printing, designed themselves. They're quite big. They can fly for about 200 kilometers at about 120 kilometers an hour on a single charge. And they fly autonomously. So we really like them, one, because they're very hardware focused. It's a little bit different from a software company. So we could provide them with a lot of support there. But they also use satellites to communicate with their aircraft over these long distances. And they use it for carting medical supplies and vaccines around. So they've been working very closely with the World Health Organization in places like Vanuatu, and they're currently in the DR Congo, to provide these services where before you couldn't do it. So they're using these interesting drones in a very novel way. Another one that's quite different is a company called JigSpace, because I'm quite fascinated by this concept of, we've got these physical locations, our physical world, and we've also got cyberspace. And so I find this convergence of cyberspace with physical space quite interesting. When you think about Earth observation data and what we're actually using that from, it comes back to things like digital twins, creating models of our planet and understanding the environment and the economy and things. And so this concept of digital twins in a different way is what JigSpace work on. So they help basically engineering firms, and they've got a lot of educational stuff as well, to easily create augmented reality models of things. So picture as easy as it is to create an image, for example, in Microsoft PowerPoint. That's what they have created for creating 3D augmented reality things. And now we're even seeing companies like, Medtronic and BAE Systems and Northrop Grumman use their software for communicating the value and helping people see their high complex engineering products in their living rooms and elsewhere, and because you can just load it up on your iPhone. So at the last iPhone 12 unveiling by Apple, JigSpace were featured as one of their prime examples of for use of their iPhone. So there are a couple of really successful companies we've worked with that are probably a little bit different to what you might be thinking of with space. Another one we worked with recently was a company called Leo Aerospace. They're actually a US-based company, and they've now got a world record for launching the first rocket off the bottom of a hot air balloon, which is a really interesting one to help them work on. And so the concept is basically you've got this hot air balloon, an autonomous hot air balloon, I should say. So we developed nice little thrusters that could actually provide the attitude control of the basket and everything. And so it would take off, basically try to go above most of the incredibly dense atmosphere so that you could have a smaller rocket that could launch a roughly 20-25 kilogram payload into Earth orbit from there without needing a big launch pad. And so the idea is that you'd be able to have, you could have all of this stuff packed into a container in a truck, take it to wherever you need it to go, and to have a launch happen basically immediately if you need to, without needing a massive launch pad. So some interesting companies that are doing some really novel things, I think, as we look at the increased demand for Earth orbit transportation is going to just absolutely explode more than I think a lot of us expect. And the technologies that we're going to need to develop to meet that demand, even in terms of things like hypersonic vehicles and things, I think the current generation of chemical-based rockets, as they are at the moment, will be great for going to Mars and for further out. But to satisfy the requirements of our Earth orbit economy that is absolutely growing, we're going to need a whole bunch of different things that are more appropriate. And so that's another one of those areas that I'm really interested to facilitate and to help companies work on around the world.
Oh, yeah, great. Thanks for that. That was very interesting. A question we have from one of our
I know there's a whole bunch of information in there. Sorry.
No worries. A question we have from one of our followers. You mentioned before a bit about what makes the ideas interesting to you of the new startups. When these companies, when people are presenting their ideas to you in their pitch, what makes them stand out and what do you look for?
That's a really great question. And I think because in the context as well of, what is in general, what are people looking for? And I think, investors and accelerators, they're all looking for different things depending on their own personal experience as well. So just a quick hot tip is, if you've got an idea and you're pitching it for investment or whatever, just remember that everyone's going to be looking for different things, and don't treat all investors the same. So what we're looking for at MoonShot, we're looking for, well, and it depends what stage you're at. So because we've got what we literally call our program stage 1, 2, 3, 4, 5. And it's stage 4 that's sort of that investment point. So if you're just someone with just an idea and you're on your own at the moment, then we want to help you develop that out. If you're talking about pitching at sort of the stage 4 level and you're looking for investment, well, what we're looking for is, are you someone that has built enough credibility to say, you are becoming, or you're very close to being the top expert in this area in the world. So if you're saying, look, we're going to be launching rockets off the bottom of a hot air balloon, I need to be able to feel that, nobody else knows that your answer is going to solve the problem that you're talking about more than you. We are looking for, so revenue, obviously, if you can have it, would be a fantastic thing. But in this area, companies, you're probably going to be focusing on the technology and R&D a lot more. But what we would like to see is that you've got an understanding of where you really think that revenue might come from. And not just by saying, so a lot of, I think a lot of engineering-based founders sort of talk about, they're like, I'm going to go mine the moon, and, there'll be customers for that. There just will be demands, build it and they will come. That may very well be true, but it's not something that you really want to rely on. So we want to be able to see that these people, if we're going to be investing in them as people, as much as their company and their idea, that they also will have the skills when it gets to that point to say, okay, how are we going to start building this actual business model out here? So I want to see, have you actually spoken to companies and to people that would actually really honestly want to purchase that from you if you were to produce it? And it has to be credible. And there's a lot of uncertainty in all of this, but it's about trying to work out, is this person able to stare into 100% uncertainty and saying, all right, I know I need to get from A to Z, but I don't know how that's going to happen. But can I get from A to B? Can I start chipping away and sort of get into the right direction? So it's about that headspace and looking at the team and saying, okay, do you have someone, if you're saying you're going to develop a company that's going to develop a novel, synthetic aperture payload for a CubeSat, for example, do you have someone in your team who can actually do that? If it's something that hasn't ever happened in history before, it's not necessarily about saying, you have to have had that experience already, but show me that you've got, that you are, that you've done some research in that area, or show me that you have developed those kinds of payloads before, or, that you are very much an expert in this area. There's always things that you can do to build up your own experience and credibility in these areas. And I think a lot of people shy away from it. They say, oh no, that will be really easy when I get there. When in actuality, usually that kind of stuff is the most difficult stuff. And so by showing me and us that you can try and persevere and sort of chip away at that, that's the best thing that you can do, I think. In terms of the actual ideas themselves, just get familiar, so rather than looking at technologies, look at problems that you believe can be solved in some way. I think a lot of groups, again, especially engineering groups, I said I am an engineer, so I totally get it. We focus on the technologies too much, and then we try to find a solution that technology can solve. That's a really, really bad way of doing it, because it's kind of like, you've got a square peg, and you're looking for a square hole, but you find round holes, and you're like, all right, let's just try to shove it in there. Instead, try to start with the problem and use your skills as an engineer to say, okay, what if I had a magic wand? This is what I love saying. If you had a magic wand to solve this problem, what would it need to do? What would that need to look like? And start from there, and then use your engineering expertise to say, okay, how do I build something that does that? That's the best thing I can advise.
Following on from that, we had another question about a smart way of assembling a team to tackle the problem that you identify. Yep. Like, how do you help your startups form a team? How would you advise people to form a team?
So I think in the beginning, so I say this, like companies that I've always started, I've always been a solo founder, and at the sort of very early stages, there is a lot of talk about, a lot of investment companies and things will suggest, don't ever be a solo founder. Like, you at least need 2 people, because the stats say that solo founders like always fail, or this kind of thing. Try not to, I think there's something to be said about trying to keep a smaller team at the beginning. And I'm not saying don't have a co-founder at all. Like, if you've got a co-founder, that's great. But what I'm saying is, if you've got a team of, say, like 5 people, sometimes that can be a little bit too much and very awkward to work out, okay, who is going to have like which positions. The best thing to do is, if you've got an idea, and if you've said, all right, I've understood, or I've at least got a hypothesis around a solution to a particular problem, build up a skills matrix. Work out, okay, let's divide up this problem to say, okay, what kind of skills are going to be needed across the board to solve this problem. Once you've done that, and try to do it in a very objective way, not trying really carefully not to be biased and thinking about who you've already got in mind for particular positions, including yourself, try to just map all that out. And then so put that on the y-axis, on the x-axis, and then on the y-axis, start to list the names or the positions that you think would be able to sort of have those positions in the bucket. That's the best way that I could suggest to build out a team. And only once you've done that, start to have a look at, okay, who do I know that really could tackle some of those things? When you're starting and you're really small, the founders generally have to do everything. And it's, there's a lot of juggling, and balancing different plates. So the more that you can divide it up as you and as you grow, you will naturally divide that up. The more that you can think about your strategy for doing that and handing over things, the better it'll be. So at the beginning, you might not be an expert at marketing at all because you're an engineer and it's like me, but you might have to do it. But at some point you have to realize, okay, I will have to find someone that has this skill to do it. And at that point, so which point of my growth, when I've got maybe 5 people, 10 people, 20 people in this company, do I hand that part over, and do I start dividing and conquering that? So at the beginning, it's a really hard question, and I know that's probably incredibly vague for what you're asking. It really depends on the specifics to give you anything more detailed than that. But it's, I think come back to that skills matrix and try to be really objective about the skills that are needed, and then try to find the people that you have around you that can fit those skills.
Sure. Yeah, that's understandable. I'll come back now to Francesco's question from before. Do you have any suggestions about startup areas that are like a hot topic at the moment that have lots of investigation going on?
Yeah, I'll start off by saying a very hot topic, launch vehicles. And I think there's going to be a huge opportunity for launch vehicles. It's great that we're seeing more smaller launch vehicles like Rocket Lab really, and pardon the pun, getting off the ground and so getting a lot of traction. I think though, there's roughly, I think probably closer to 300 now. I don't know, but last time I checked, there's about 200 launch startups across the world at the moment. I think that is just too many. I think if you really want to start a space company, go back to like I said, go back to looking for a problem. Don't just automatically jump to, hey, I'm going to build another rocket. Just because there's so many out there, and you're going to really struggle to get the support you need just because there's so much noise. So there's that. But things that I'm really excited by, I love the development that's happening with things like ion propulsion systems and starting to look at, on-orbit servicing. We've got a lot of stuff already up there in space. So how do we utilize that? How do we recycle it? How do we resell it? So, things like space tugs will soon be possible once we can have, efficient, incredibly small ion propulsion systems. There's a number of groups across the world that are developing those out. There's a number of groups that are looking at things like space tugs. You've got Orbit Fab in the US, for example, and I'll flag them because one of the founders is an Aussie. So they're looking at already putting some basically stockpiles of xenon up into space, so that once they have the capability to actually move that xenon around, they'll be able to refuel satellites and things like this. I think that's going to be absolutely amazing, because at the moment, as I'm sure you're all aware, launching, especially the bigger satellites, launching a satellite, it's like buying an iPhone, brand new, but you only get one battery charge. And so it runs out and then it's just still up there, and everything else is perfectly fine, but there's just no fuel in it. What does that mean if you can suddenly refuel it once? Well, you've just doubled the life of this computer that can now provide a whole lot of extra value. What if you can resell that? So I'm really interested in companies that are looking and trying to tackle the legal requirements, especially the international geopolitical issues around selling assets that have already been launched into space to other buyers, especially if they're from a different nation. Where, you know, for example, if you've got a US satellite and you're trying to sell it to an Italian buyer, for example, and all the complexities with that. I think that will mean that there'll be a lot less need for companies to say, look, I need to build another satellite from scratch and get that launched and put more stuff into space. So in terms of the space junk problem, I think that will help solve a lot of it. But also from an economic standpoint, I think it would become a lot more viable. You know, roughly, let's just say that we're still at $20,000 a kilogram to send something up. Well, there's a whole bunch of stuff that's already up there. So that's incredibly valuable if we can reuse it. Other things that I'm really excited by, that probably not so many people are unless you're really into that sort of data and analytics, is the actual what we're going to be using a lot of this Earth observation data for back here on Earth, and how we're funneling that into industries like agriculture and mining and other things as well. I think that we, you know, like big data was in the tech industry, you know, 10, 15 years ago, I think we're really soon going to discover that there is so much more gold in that data than some of us can even perceive now. You know, the fact that Walmart in the US have been using Earth observation data from Planet to optimize the layout of their stores by looking at the metric of how many cars were parked out the front of their stores. Like, that's incredible. And it sounds like an absolutely ridiculous and absurd use of space assets. This you know, we really talk this up, but it's really cool. And it's, you know, this is something that's going to open up more and more to these, you know, seemingly boring areas of the economy. And that's absolutely great. That's what we want to have happen. We want space to become boring, because that's when it becomes, you know, such a key, even more of a key part of our economy and everything we already do. Yeah, to be honest, I could keep going on with things that I'm just so excited by with space, from like the deep technologies. I'm in love with what's happening on the advanced manufacturing front, from, you know, like new ways of manufacturing rocket engines, and, you know, what we were seeing, you know, with like people testing aerospikes and things like that now. There's a whole, I could keep going on, but I might stop there. Unless there's more questions later that can, you know, you want to keep asking me, I'm happy to talk. Sorry, mate, you're on, I hate to say it, you're on mute.
I thought I would have learned how to do this by now. I think, yeah, thanks for that answer. We might switch to some questions we have on the live stream now.
Sounds good.
So, yeah, what would you suggest to students with lots of ideas but little know-how?
I think I've got it. Yeah. So the first tip I'd probably say is drop, get the word entrepreneur out of your mind. I think, you know, especially if you start thinking about it in terms of like, okay, entrepreneur. I think that'll probably set you on the wrong path. Instead, you want to be a problem solver. And that's why I think that, like, as engineers, you know, we're sort of already a bit of a step, you know, ahead of the curve there, because we literally are engineers because we try to work out, well, what do the physics of the universe say? And then how do we solve problems by taking advantage of those facts and those rules? So breaking this rule for a second, the best entrepreneurs, the most innovative people that solve the best problems, I think, are people that do have lots of ideas. And lots of ideas is a fantastic thing. It's your ability then to run really, really quick, small experiments on each of those ideas, and to start drilling down and sort of just chipping away and working out, okay, how do I keep evolving this idea, and to make sure that it's going to really be great at solving a big problem. You know, and at some point you might realize, okay, this idea just isn't working. So you drop that off and you work out, okay, well, what's the next most valuable idea that I have? So I always suggest to anyone that really wants to, you know, be an amazing engineer or an amazing entrepreneur, you know, keep a list of these ideas, and I've got one as well, and develop them out, and you know, you might come back to an idea a year later even, or somewhere else, but it's just sort of keep chipping away at them, but keep them there. It's all about using that. I love the scientific method, and I think it applies for things outside of science as well. And this is exactly one of those problems. You've got this idea, which is a hypothesis. It's a total assumption at the very beginning. You know, and a lot of people say, I've got this great idea. I'm like, well, the greatest ideas are ones that you've built into a business or built into a technology that's already doing something great. And there's no doubt about it that it was a great idea because it's already worked. before that, you don't know that an idea is truly great until you put it to the test. So find little experiments that you can do to take away some of that uncertainty around that assumption. So just realize that every idea you have starts off as a pure assumption. And the more that you objectively chip away at it by saying, all right, what's the hypothesis? What's an experiment that I can run? Okay, how can I now, take these learnings and put that into my new hypothesis? That's the best way to test out a lot of these ideas. I wish that you could be on screen so I could dive into one of your ideas with you and sort of show you what that might look like. But maybe we'll have to keep that for another time. Okay, so Aussie universities don't cover all fields of space research, and this is a lot of international universities as well. So do you think that the increment of space startup in this situation will change? So a startup can also have an impact on the academic world. And do I have an example that I can talk about? I think that, when I started the Melbourne Space Program, for example, we didn't have, at the University of Melbourne, we didn't have any space program at the university. We didn't even have, there was just nothing happening with space at all. By the time I left the Melbourne Space Program, I think there was about 3 or 4 different satellites being worked on across different departments and things. And not necessarily because of us. I think, just that activity was there, and, we sort of started developing an ecosystem between the schools and things. And so, and I'm seeing similar things happen in universities, like, from the other way around, like UNSW, where there's a lot of academic space stuff happening, and even UNSW Canberra and University of Sydney. And now we're starting to see more commercial spin-offs and startups coming out of that, whether that's the university themselves spinning off some research that they've been developing, or whether it's researchers that have been working on this that have got this great experience now saying, hey, I want to do this out on my own. I won't be unfair and pick out on specific examples, but I'm seeing a lot of this happening across the board at the moment. And so I think it will be something that continues to increase, both, more startups that are coming out, both, not necessarily just because of university. I think something like space, where it is inherently deep tech, there will always be that big sort of heavy, academic side of things, where that will be that big incubator of these ideas and these kinds of opportunities, but also the research as well. And we're seeing this, a lot of countries around the world, not just Australia, have been developing new space agencies recently. Another one that I'm excited by, that will pop up soon is the Philippines. Most countries have a space agency now. And I think that's because a lot of these nations are realizing that there's a huge opportunity for space, and, space infrastructure already, like I say, already does underpin all of our industries across every part of the economy. And so if you aren't developing out that capability within your, local national capability, then you're going to be held behind. And so I think that impact is going to, a lot of universities around the world are going to start seeing that more and more, as they already are, and focusing more heavily on space, especially now that it's becoming cheaper. So if you're if you're a school of a university and you don't have so much funding, well, now you can launch your own, let's say an astronomy satellite, CubeSat, let's say it's, an infrared satellite that points out at the stars, 6U CubeSat or something. You can do that now as a minimally funded team, whether it's an academic one or not. So I think that all these things, there's this commercialization of space is inherently tied to the academic side of space. It's going to continue to absolutely increase for sure. So what are some of the common struggles that startups you've worked with have encountered, and how did you / the startup solve those problems? That's a very, very good question. I think the one that comes to my mind is actually one that we've just spoken about, which is, how do you develop that? How do you grow your team, and what do you look at when you're doing that there? Because at the moment, there's a whole bunch of new people coming into the space industry. And if you're in Europe or the US, you're in a much better position than most other places in the world, because you can say, you've got this problem of saying, all right, I really need someone with more specialist experience in this particular, we need to develop a new kind of thruster or something, or whatever it happens to be. Well, you can generally find, it's going to be hard to maybe there's more demand for them, maybe it would be very hard to get them to come to join your startup, especially if you don't have so much funding to pay them what they are used to getting paid. But you at least have access to them. I think a lot of other countries around the world are really, and Australia is one of these too, where we've got some really amazing people in Australia that have gone overseas, and they're not necessarily coming back yet. A lot of them are. So if you're a startup, how do you get access to that talent? That itself requires you to put together a strategy. And so that's one of those extra hurdles that space and deep tech companies have that maybe a software company doesn't have, because it's very easy to learn how to write code these days. Other problems that I think a lot of startups have, especially on the very early side, is just is focusing too heavily on the technology and not really thinking about what will this business model look like? What is the marketing side of this going to look like? And how do you communicate the value of what it is you're doing to the wider world? Because that's how you get, by telling that story, that's how you get both people to come and help you build it, whether that's people joining your team or advisors or whatever it happens to be. That's how you attract investors or sell, if you're applying for a government grant or something like that, or even a contract. That's, it's all about selling. And so that communication side is something that a lot of space startup entrepreneurs really struggle with, because they've always got their heads so close to the page of the technology and what it is that they're building, that they're just too close to the problem to be able to handle that stuff. And then that hampers their progress, because you really need to be able to do all this stuff at once. So that's another one as well. So try to broaden your horizons a little bit, and practice your storytelling and communication, and just working out, okay, why should people really care about what it is that I'm doing? Not because it's cool, but what problems does it solve and what value does it add to the world really? So if you say, for example, okay, we know that there's helium-3 on the moon, and we're going to develop a way to mine that. Okay, so we can talk about all of the logistical challenges of getting that helium-3 back to Earth, and maybe you've got solutions to that. But in realistic terms, what problem is that solving for who today? How are you actually going to monetize that? Or is it just going to be a really cool, glorified hobby project? Because there's a lot of risk in doing something like that. And so startups, especially in the venture industry, risk is a good thing. But there comes a point where it's like, well, look, if there's not really any credible way, even on the science fiction side of things, of making this a commercially viable thing in the near future, then there's not much point in doing it just yet. So being really managing your expectations around that story and understanding, okay, what value is this going to create and for who? It's about understanding that customer and that all that sort of stuff. That's the next biggest challenge, I think.
Oh yeah, I guess we'll squeeze in one more question if you've got time.
Yeah,
for that,
sure.
Troy.
Well, this is a great one. Do you think space tourism will be possible in the future? So I'll try not to draw this out as much as I want to answer this properly. So 100%, and I actually believe that we already have space tourism. I think that the emergence of things like augmented reality and virtual reality will enable us to do some truly amazing things where, we will be able to get the sensations, and we will be able to, get exposure to outer space and space tourism without even necessarily having to physically go anywhere. I think that exponentially decreasing prices of access to space for things like Virgin Galactic, and even your access to things like the International Space Station, will eventually also enable things like space tourism. But I think in the near term, there's a really interesting thing to be said around things like virtual reality. So there's one company that I was talking to just recently who is, and I love this idea, who is looking into providing, I don't know if I should talk about it, because I don't know if they would be comfortable with me sharing it. It's something I always say, look, if you've got a good idea, if you've got an idea, then share it, because it's good to get the feedback. And the most passionate people are the ones that should get it anyway. But I'm not going to talk about someone else's idea, because I'm not sure if they want me to talk about that yet. But virtual reality, I think, is a really good one for space tourism. I put a lot of thought into around as well. I don't think a lot of people on Earth really just don't feel that space is a tangible thing. And I think that's a little bit sad. I think that even 100 years ago, before we had global positioning systems and things like this, we were all inherently much closer to space. I think we would have all felt like we were space tourists already, because when we look up at the night sky, we don't have all the light pollution. When we're flying a plane or steering a ship around the oceans, we had to navigate using the stars. We've actually become less space tourists recently, because of all this technology that sort of shield us away from it. But I think technology is going to help bring it back. Like I said, I think that virtual reality, augmented reality, they're two of the things that will make it really tangible and possible for us to really sort of connect with it in the near term. But also things like physically being able to go to space, or being able to use products that have come from space. That is another one as well. So one of the answers I should have given for the last question as well was, I'm fascinated by the idea of pharmaceutical manufacturing using microgravity to do chemical reactions and things that you simply can't do here on Earth, to manufacture new medicines and things. I think that, if you have to take a new medicine, a novel cancer drug, for example, that was manufactured in Earth orbit, that itself is a way of space tourism. It makes you feel more connected it will make you feel more connected with the universe. If you have, a fiber optic cable to connect your speaker system to your TV, because that fiber optic cable can be produced in such an incredibly fine-tuned, pure way compared to what we can do on Earth, then that as well, to be able to say, okay, rather than paying $500 for a 1 meter cable that's, say, gold plated or whatever it is that's the latest marketing for that kind of electronics, try to say is great. You can say, well, this is really cool because it's literally manufactured in space, but also there's actually truth to the fact that it's a better quality product too. So I think space tourism is an interesting one when we think about the blurred lines between, one thing I like to ask people is, where do you think the edge of space really is? And my answer for that is, well, there is no edge of space, and it's becoming increasingly blurred, and that's a great thing. Sorry, I know that was a bit of a rant. I was trying to squish it in. I could have spoken for an hour on that.
Okay, sorry, we have one more question from the followers, if that's all right.
What about what if your startup? And so if your startup works in the end, what are the? Sorry, I lost the question. Where'd it go? Or is it this question?
2 seconds.
That's all right. Sorry.
This question here on the screen now.
Oh, it's this one right here. Okay, so what about the increasing number of space debris in orbit? Is it a big issue, as they say? So it's a really interesting one. I think, look, the simple answer is yes, it's definitely a huge issue. It's not as simple as most people expect, though. So I mentioned before that, a lot of the space junk that we've got up there isn't necessarily a write-off yet. And a lot of it can be moved, or has already moved, into a junkyard orbit where it's not necessarily an issue. But a lot of it can be refueled, or a lot of it is just simply a matter of, we've got a lot of stuff up there now. So Peter Beck from Rocket Lab, CEO and founder of Rocket Lab, just a few weeks ago, last month maybe now, mentioned that there's this really big problem about trying to work out, okay, I've got to launch a rocket through all this stuff now. How do I navigate this? So even with the amount of what have we got? Roughly, I think 6,000 pieces, like satellites and pieces of junk up there at the moment. Most of them are not active, but that itself is already causing an issue for navigating and sort of launching new missions, as Peter has pointed out. So that is already becoming a big problem. And SpaceX haven't even launched a significant fraction of their 42,000 satellites yet, not to mention all of the other companies like Fleet Space and others that are looking to launch hundreds and thousands of more satellites. That said, like I said, I think that the idea of what I'll just quickly describe as space recycling and refueling and things, that will help that quite a lot. I think that there will inevitably still be a tragedy, the common situation where companies, like we're seeing with SpaceX, they're absolutely inundating the FCC with applications to launch all of their satellites, and that is regulation, so that they've got a much more well-funded legal team than the FCC have, and so they know that they're doing this on purpose. They're using the law against the government, basically. But that locks out not only other companies from using those orbits, it locks out everyone on Earth from being able to use those orbits. So even stuff that isn't necessarily put into space yet can block and create junk. There's a whole bunch of issues that we have to use. It's going to be a mixture of technology. It's going to be a mixture of politics and negotiations on a geopolitical scale. And it's going to be a mixture of the space laws that we're going to be introducing, things like the Artemis Accords and whatever comes after, as the next iteration of the next add-on to the Outer Space Treaty and things like this. These are all going to be things that we need to move on now, and will help us deal with this debris in orbit. Because I think it's not as clear cut and it's not as simple as most of us think of it. Especially if you say, well, a lot of these satellites are in use. So are they junk or are they not? How do we best make use of the space that we have?
Sure. Thanks for your time. As a closing question, if you could choose one thing, what's the one piece of advice you would give to a new graduate who's hoping to start a career in the space industry in the coming years?
So the biggest piece of advice that I would give, especially for someone with an engineering degree under their belts, is don't be afraid to jump in and just say, hey, I want to try to do this really big, amazing thing. I think a lot of people spend a lot of time saying, I'm going to go get some experience and I'm going to go do this, I'm going to do that. And then maybe eventually I'll start this company. I've got this idea and, I just want to get some experience first. The best way to get experience, I believe, is to go and actually try doing it and to build it firsthand. Rather than trying to learn it in textbooks and this kind of thing. Doing your engineering degree gives you all of the foundations and all of the tools you need to work out, okay, you go to uni not to learn all the intricacies of your degree. You go to university to learn how to learn. So take those skills when you graduate and say, okay, what is the quickest way I can learn? And it's usually to jump in the deep end. Whether that's saying, all right, I'm going to go and work for this startup as opposed to going to work for one of the big aerospace primes where most of the time you're probably doing paperwork and things, or it's going to start your own company yourself. Do that because we need more people to become innovative problem solvers. We need more people to say, all right, I'm going to try to start my own deep tech business because I know how to build technology and I've got this great idea to solve a problem that no one else has this perspective of yet. So let's just try it out. And let's take that chance. And this is why, and if you are in that boat, come and talk to me at MoonShot because this is exactly the kind of framework that we're looking to build to try to support you so that you have that safety net and that support to be more likely to be successful.
Great, thanks. What's the best way for people to contact you at MoonShot? Just your email address or LinkedIn? What do you prefer?
Yeah, so connect with me on LinkedIn. I'm on Twitter as well. I'm much more active on Twitter than I am on LinkedIn. I'm terrible with the DMs though. So usually if you send me a message on there, I'll usually give you my email address. If you connect with me on LinkedIn, make sure you include a message just telling me like where you met and all that kind of thing. I much prefer that over just a cold connect. But yeah, usually email. So feel free to, Lyle, you can send my email out afterwards if you'd like. It's a little bit inundated at the moment. I might be a little bit slow to reply just because we've got a few things happening, but I promise I'll get around to it, and I'd love to have a chat.
Yeah, sure. Thanks for your availability. Thanks again for your time today. We'll let you get back to your Thursday night in Melbourne. The time difference created some problems organizing this, but yeah, thanks for being flexible.
No, it's okay. No worries. No problems on my part. No, it's been an absolute pleasure. Thank you so much, and I hope everyone enjoyed the talk. And I hope that I'll see some of you soon.
Yeah, likewise. It was great talking to you.
Yeah. Ad Astra, everybody. Thanks very much.
All right. Thanks. Bye.